right, so now we are ready to start our volume looking at a different situation. All right, so far we did the disk method. So now we're going to do what's called the washer method, and I'll show you what that means, what the difference is. So we're going to find the volume still by taking the area and revolving it around the axis. We're still going to do that, except now the method we're going to use is the washer method, which is slightly different from the disk method. Now, when we get volumes, remember we're rotating our shape around an axis. So we're rotating around this axis. This comes down here. It rotates around in a circle, and we get a three-dimensional object. Again, rotating around here. This comes on this side. We're rotating in a circle, so we get a three-dimensional jug shape. Same here. You're rotating this shape around this line, so it ends up being kind of an egg shape solid or potato. All right. Now, what's different with what we're going to do today, and we did this horizontally too, vertically too. I won't go through and show all those because I think you're good with that. It's just when you do a rectangle, when you rotate this rectangle around here, it makes a cylinder, right? And when you rotate a triangle around an axis, it makes a cone. Just want to review that real quick. All right, but we can take any of these objects and we can rotate them around an axis to create a solid three-dimensional shape, and we're finding the volume of that. So what's different with what we're doing today, or in this lesson, part of the lesson, is what you're rotating does not touch your line. Or if it touches it, it doesn't touch it in the whole, along the whole edge. It may just touch it in one little point, and then it goes off the line. So if you look on the last ones we just did, our objects all were touching the line, right, that we went around. So right here it touched the line, here it touched the line, and here it was actually up against the line, touching the line. So the difference is our objects that we're rotating now don't touch the axis of rotation that we're rotating around. So what happens when this rectangle rotates around this line, the rectangle is going to come down here, and this rotates in a circle. So you end up with this going on. So it looks like a roll of toilet paper. And in here is a hole. So there's a hole, just like the hole through the toilet paper. So there is a hole all the way through our solid that we have. So before we didn't have that. Before we had a solid shape all the way through. Now we're going to have shapes that have a hole through the middle of them. All right, so take a look at what's going to happen here. If I take this little leaf and rotate it around this horizontal line, my little leaf is going to come down here, right? But yet this is rotating in a circle. So you're going to get this circular look here. So this is going to look like a bowl with an inverted like tornado on the inside. So it's going to be kind of have this ridged edge going into a point in the center. All right. So that gives us a three-dimensional object, but it has a hole on the inside. All right. It's going to be a bowl with a hollowed out inside, and it's going to curve towards the center to a point. All right, so this time when we rotate the area around our axis, it doesn't totally touch the axis, so there ends up being a hole in the middle of our solid. So how does that affect our problem? Okay, well, this is the same slide I had last time. We're still going to take our area and chop it up into little discs, okay? But what's going to happen is our discs this time, every one of our discs is going to have a hole in the center of it, okay? Which means we just need to find the volume by subtracting. We're going to take the volume of the big disc, and then we're going to take the volume of what we consider maybe a little disc, which makes the whole, and we're going to subtract those. All right, so we're going to have a disc with a big radius. So we're going to have a big radius for the disc from here, from the axis all the way out to the edge. All right, so that's going to be our big disc. All right, and then what makes the hole here is a little radius. I've got them listed out here on the side. So this is big R, and then we've got a little radius of a little disk that's punching through the center. And so we are going to take the volume of the big disk and subtract the volume of the little disk. So that's all that's going to happen here, okay? So this is what's going to happen. The volume of our washer is going to be the volume of the larger disk, which is the circle, pi big R squared times its width, minus the volume of the smaller disk, which is going to be another area of a circle, pi little r squared, with the same width, okay? Both of these have the same width. So we're going to take the volume of the bigger, we're going to take the volume of the bigger one, and then we're going to subtract the volume of the smaller one. So we have the big disk, and then we have our little disk. They both have the same width, and we're going to subtract those two volumes. Now, when we do that, you can factor out the pi and the w, okay? And that'll leave you with big R squared minus little r squared. So then this is our formula for washer if something has a hole in it, all right? So you notice the only difference in this formula is we're subtracting a little r squared. That's the only difference. So we're still doing an integral from a to b. We still are multiplying by pi because these are all circles. We're rotating around, so it's got to have a pi in it. And then we're doing the big radius squared minus the little radius squared dx. And just like before, your axis will always be in both of these r's, okay? So this will either be a function minus your axis or the axis minus the function, both of these, okay? So it's pretty much the same process. It's just we have to do big R squared minus little r squared. All right, so let's try some of these, and I'm going to do a separate video again so that you don't have to sit through one big long video. I know they're long enough already. So that was your content video.